In the world of AI, you've got these giants, right? Google, OpenAI. They have billions of dollars, armies of researchers. And then, sometimes, you have a single person working on their own. Today, we are diving into a story that feels a lot like David versus Goliath, all centered around a major breakthrough on what just might be the toughest AI test out there.
So let's start with a number just to set the stage. This is GPT-4's score on graduate-level STEM questions. I mean, it's an absolute beast, right? A massive library of knowledge that can crush just about any fact-based question you throw at it. It's truly, truly incredible.
Okay, now hold that 98% in your head. What if I told you that the very same brilliant model scored a measly 3.4% on a different kind of test? Yeah, you heard that right. It goes from being the top of the class to, well, completely bombing the test. And that huge drop, that's our first clue that we're talking about a totally different kind of intelligence.
And that gets us to the heart of the mystery here. How can the world's most sophisticated AIs, models that can write complex code, pass the bar exam, how can they fail so badly at a test that, when you look at it, just seems like a bunch of simple puzzles? What is this test, and what is it telling us about the limits of modern AI?
So to figure out why they fail, we first have to really understand the test itself. It's called the Abstraction and Reasoning Corpus, or ARC for short, and you can think of it as a kind of IQ test, but specifically for machines. The whole point of ARC-AGI is to get past an AI's ability to just memorize the internet. It's not about what it knows, it's about how it thinks. The test is built to measure genuine, flexible, problem-solving skills, the kind of core reasoning we humans use every single day without even thinking about it. So how does it work? Well, for each puzzle, the AI gets a few before and after pictures of a grid, and its job is to look at those examples, figure out the hidden rule, the pattern that connects them, and then apply that same rule to a brand new grid. There's no way to cheat this. You can't just look up the answer. You have to actually understand the logic. And when you look at the scores, you see this massive gap. The average person, they score around 77% on these things. Before this breakthrough we're talking about today, the best AIs were stuck down at about 54%, and GPT-4, as we saw, it's way down at 3.4%. I mean, this isn't just a small gap, it's a chasm. It showed us that AI was really missing something fundamental. For years, the entire AI community was basically just hitting a brick wall trying to solve this. They had some really clever ideas, but every single one of them had a major critical flaw.
So there were pretty much two main schools of thought. On one side, you had what's called evolutionary test time compute. Think of this as the brute force method. It was powerful, yeah, it could try thousands of solutions, but its big weakness, it started from scratch on every single problem. It had zero memory. On the other side was DreamCoder. Now this one was smarter. It could actually learn concepts and reuse them, but it was super rigid and needed a lot of handholding from humans to even get started.
And this quote just nails the problem perfectly. These systems had to relearn every concept for every task. I mean, just imagine if every time you went to tie your shoes, you had to rediscover the idea of a knot from scratch. It would be insanely inefficient, right? Well, that's exactly what these AIs were doing. But hidden inside the limitations of one of those older models was the seed of a truly brilliant idea, and it all came from the concepts behind DreamCoder. The really clever bit about DreamCoder was this idea of a wake-sleep cycle. During the wake phase, it would go out and try to solve problems. But then, in the sleep phase, it would actually think about the solutions it found, and it would boil them down into reusable little building blocks, concepts that it stored in a library. It was an AI that could actually learn from its own experience. And this is the light bulb moment, the big aha. What if you could take that beautiful learning loop from DreamCoder, that ability to build a library of knowledge, and you could pair it with the raw, creative, code-writing power of a massive large language model, an LLM like GPT-4? Could you finally get the best of both worlds? Well, that is exactly what a researcher named Eric Pang decided to find out. He built a totally new system, a hybrid that fused these two ideas together. So the absolute key here is this learning loop. Let's just walk through it real quick. First, an LLM acts like a creative brainstormer, just spitting out potential programs to solve a puzzle. Then, the system tests them to see if they work. Now, if a program is successful, it doesn't get thrown away, it gets added to a permanent library. And here's the magic. For the next puzzle, the LLM gets to use that library as a cheat sheet, helping it come up with even better ideas. The system literally gets smarter as it goes. This diagram from the paper shows the whole thing in action. You've got the LLM generating ideas, a tester checking them, and the good stuff, the successful programs, feeding back into that ever-growing library. And that library then helps with the next task. It is a beautiful, self-improving cycle that constantly builds on its own success. A lot like how we humans learn.
So, the big question is, did it work? Well, the results, they weren't just a small step forward. They completely redrew the wrap of what we thought was even possible on this test. Okay, take a look at this graph. This shows the old state-of-the-art. Each dot is a different AI model, and you can see this clear line. It was a trade-off. You could either get higher accuracy or you could have a lower cost, but you could never have both. The whole field was stuck on this curve.
Now, look at the new numbers. The old champs scored about 54% and cost almost $29 per puzzle. Pang's new system? It hit 77.1%. That's basically matching human performance, and it does it for about $3.50. It doesn't just beat the old record, it absolutely demolishes it.
And let's just pause on that efficiency for a second. It's not just more accurate. This new system is 8 times more cost-efficient than the previous best. That is a massive leap. We're talking about doing so much more with so much less.
And that's why this is such a fundamental breakthrough. The system didn't just inch along that old curve on the graph, it completely shattered it and created a brand new one. This is what's called creating a new Pareto frontier. It means it's not just better, it's smarter. It's a whole new, more efficient way of solving the problem. Which really leaves us with this huge, exciting question. For so long, AI has been fantastic at recognition, at finding patterns in data we already have. But this breakthrough is a huge step toward an AI that can truly reason, an AI that can build up its own knowledge and apply it in new, flexible ways. So the question isn't really if AI can learn to reason anymore. It's what happens when it does. What currently impossible problems is it going to solve next?